Welcome students, welcome again to my another new lecture. I am Muhammad Tanbir Ahmed, lecturer, Department of Civil Engineering, World University of Bangladesh.
Why COD is greater than BOD? Generally, COD is greater than BOD because COD is a chemical process and BOD is a biological process. So, more compounds can be chemically oxidized than it can be biologically oxidized. This includes chemical toxic to biological life, which can make COD test very useful when the testing industrial sewers, as they will not be able to capture by BOD testing. So we can say COD can capture chemical toxic to biological life, which is not possible by BOD testing. Another big advantages of COD test is that it only takes approximately 3 hours as opposed to 5 days required for BOD testing. Importance of BOD test. The test for BOD is very important as it grants uniformity while comparing with various results and tests. It helps to finding out the amount of clear water required to treat the wastewater to safely discharge into environment. We know BOD directly affects the amount of dissolved oxygen in rivers and streams. The greater the BOD, the more rapidly oxygen is depleted in the stream. This means less oxygen is available to higher forms of aquatic life. The consequences of high BOD are the same as those for low dissolved oxygen. And we know in low dissolved oxygen water, aquatic organisms become stressed, suffocate and die. So it is very important that the BOD should be in the standard range. In most pristine rivers, the BOD should be less than 1 mg per liter. In moderately polluted rivers, the BOD should be in the range of 2 to 8 mg per liter. In ordinary domestic sewers, the range of BOD should be within 150 to 200 mg per liter. In municipal sewers, which is efficiently treated, the range of BOD should be less than 20 mg per liter. Any effluent to be discharged into natural bodies of water should have BOD less than 30 mg per liter. Drinking water usually has a BOD less than 1 mg per liter. And when BOD values reaches 5 mg per liter, the water is doubtful in purity. The water quality depends on BOD level. When the range of BOD is 1 to 2 mg per liter or parts per million, that means the water is very good and there will not be much organic waste present in the water supply. When the range of BOD is 3 to 5 mg per liter, the water is fair, that means it is moderately clean. When the range of BOD is 6 to 9 mg per liter, the water is poor, that means it is somehow polluted. Usually it indicates organic matter present in the water and bacteria are decomposing this waste. When the range of BOD is 100 or greater, the water is very poor, that means it is polluted and it may contain organic waste. These are the formulas which are used in calculation of BOD. The first formula is used to calculate the biochemical oxygen demand at any time t. Then this formula is used to calculate the ultimate biochemical oxygen demand L. This formula is used to calculate the deoxygenation rate constant, which is K. This formula is used to calculate the time for oxidization, that means the time required to complete the BOD process. This formula is used to calculate the seeded or diluted biochemical oxygen demand, and this is another formula which is used to calculate the seeded or diluted biochemical oxygen demand. The notations used with the formulas showed in the last page has illustrated here. Here, BOD equal to biochemical oxygen demand, L equal to ultimate biochemical oxygen demand, K equal to deoxygenation rate constant, T equal to time, D1 equal to initial diluted seeded wastewater dissolved oxygen, D2 equal to final diluted seeded wastewater dissolved oxygen, B1 equal to initial diluted seeded sample dissolved oxygen, B2 equal to final diluted seed sample dissolved oxygen, F equal to seed volume ratio, and P equal to wastewater decimal fraction. Here is an example which is the calculation of biochemical oxygen demand. Let's read the question first. Determine 1-day BOD and ultimate first stage BOD for a wastewater whose 5-day BOD is 200 mg per liter at 20 degrees Celsius. So a wastewater whose 5-day BOD is 200 mg per liter and it is observed at 20 degrees Celsius is given. And we have to calculate the ultimate BOD for this wastewater, and also we have to calculate the 1-day BOD for this wastewater. The reaction rate constant K equal to 0.23 per day, which is given in E base, that means it is in lone batch. What should have been the 5-day BOD if the test had been conducted at 25 degrees Celsius? Look that this 5-day BOD is in 20 degrees Celsius temperature, and if we change the temperature at 25 degrees Celsius, then what would be the BOD? We have to calculate this. Let's try to solve this question. First, we have summarized what are given in the question. Here, K equal to rate constant, which is 0.23 per day, and it is given in question. BOD 5 equal to 200 mg per liter at 20 degrees Celsius, and it is also given in question. We have to calculate the ultimate BOD, which is L. BOD 1 at 20 degrees Celsius, that means BOD for 1 day, and BOD 5 at 25 degrees Celsius, that means BOD for 5 day at 25 degrees Celsius temperature. We have to calculate ultimate BOD L, and to calculate ultimate BOD we will use this formula. L equal to BODT divided by 1 minus e to the power minus KT, where BODT is the BOD after any time t, and in question the BOD for 5 day is given, so we have to use BOD 5 as BODT, and its value is 200 mg per liter. The value of rate constant K is given in question as 0.23 per day, and this value T will be 5 day, as this BOD has been conducted in 5 days. And finally, replacing all these values, we will get ultimate BOD L equal to 293 mg per liter. Again, we have to calculate 1-day BOD. To calculate BOD after any time, we can use this formula BODT equal to L into 1 minus e to the power minus KT. Here, as we have to calculate BOD for 1 day, so we will use T as 1 in this equation. The other value will be same. L naught equal to ultimate BOD, which is 200 mg per liter. K is the rate constant, which is 0.23, and T is 1 day, as we have to calculate 1-day BOD. And finally, we get BOD at day 1, or BOD after 1 day, is 60.1 mg per liter. Our last and third question was the BOD after 28 BOD 5 at 25 degrees Celsius temperature. To calculate BOD 5 at 25 degrees Celsius temperature, first we have to calculate the rate constant for 25 degrees Celsius temperature. To calculate the rate constant, we can use this formula KT equal to K20 into 1.047 to the power T minus 20. Here, by this equation, we can calculate the rate constant for any temperature. The rate constant which we want to calculate is at different temperature is T. That means T denotes the temperature. Here we need to calculate temperature for 25 degrees Celsius. So we will use T as 25. So this is K25. The value of K20, that means rate constant at 20 degrees Celsius temperature, is given in question and it is 0.23. If it is not given, we will use normally 0.1 for this K20. And T is the required temperature, which is 25, and finally we get K25 equal to 0.29 per day. Finally, we can calculate BOD after any time t using this equation, BODT equal to L into 1 minus e to the power minus kt. The similar equation we have used when we had calculate BOD after 1 day. Here t is the required day for which we want to calculate BOD, and other things will remain same. L is the ultimate BOD, which is 293 milligram per liter. K is the rate constant, and this rate constants will be for 25 degrees Celsius temperature, which is 0.29 per day, and T is the time, and here BOD need to be calculated after 5 days, so this T will be 5, and finally we get BODT equal to 224.27 milligram per liter. Here is another example. Let's read the question first. A BOD test was conducted at 20 degrees Celsius in which 15 milliliter of waste sample was diluted with dilution water to 300 milliliter. That means the sample water is 15 milliliter and it was diluted with fresh water, and the total volume will be 300 milliliter. That means diluted fresh water volume is 300 minus 15, that means 285 milliliter. The other data are given here. Initial DO, that means initial dissolved oxygen of diluted sample, which is D1 equal to 8.8 milligram per liter. Final DO after 5 days, which is D2, and it is equal to 1.9 milligram per liter. Initial DO of seeded dilution water, which is B1 equal to 9.1 milligram per liter. Final DO of seeded dilution water, which is B2, and it is given 7.9 milligram per liter. We have to calculate 5-day BOD at 20 degrees Celsius for this sample. To calculate diluted or seeded BOD, we have to use this formula. BOD equal to D1 minus D2 minus B1 minus B2 into F divided by P, where F equal to seeded volume factor, which can be obtained by dividing the volume of diluted water, which is 300 minus 15, that is 275 milliliter. That means it is the volume of fresh or distilled water divided by total volume, which is 300 milliliter, and finally F stands 0.95. P equal to wastewater decimal fraction, which can be obtained by sample volume divided by total volume. Our sample volume was 15 milliliter and total volume was 300 milliliter, so finally P becomes 0.05. And if we replace all these values in this equation, we can calculate BOD after 5 days, and the value becomes 115.2 milligram per liter.
That is the end of our today's lecture. Thank you everyone.